For decades, astronomers have been staring at a cosmic dead end, a thick, impenetrable shroud of dust that was hiding the hearts of some of the most active galaxies out there. But now, thanks to the James Webb Space Telescope, that shroud has been torn wide open, solving a puzzle that's been bugging us for 40 years.
Now, to really get why this is such a huge deal, you have to understand what we used to think. For almost 40 years, the scientific community just kind of accepted that the supermassive black holes at the center of galaxies like Circinus were, well, off limits, forever hidden behind this wall of dust. It was basically an accepted fact, an insurmountable barrier, right in our cosmic backyard.
So what was this barrier exactly? Let's dive into the long-held theory that basically built this cosmic wall in our minds.
All right, the idea was called the canonical torus model. And I want you to picture a giant, perfectly smooth, solid donut made of dust and gas. This torus, as they called it, was supposed to be wrapped around the supermassive black hole, completely blocking our view. Seriously, think of it like a cosmic brick wall, so thick and so dense that no light could possibly get through, leaving us totally blind to all the chaos happening on the inside.
But hang on, if no light could get through, how do we finally peek behind the curtain? Well, this is where the hero of our story comes in. The James Webb Space Telescope. You see, Webb has a superpower. Its mid-infrared instrument, or MIRI, doesn't see visible light like our eyes do. Nope, it sees heat, and that is the key. While that giant dust donut blocks normal light, it can't hide the heat radiating from within. MIRI's incredible infrared vision allowed it to peer right through the dust, basically shattering that 4-decade-old barrier.
And Webb didn't just get some blurry glimpse. Oh no, it gathered a mountain of data, which we can actually break down into 4 crucial clues that completely overturned the old model.
These clues are like the 4 pillars of this new discovery. First, we're going to look at the structure of this dust cloud, what it actually looks like. Then we'll check out its composition, what it's really made of. After that, we'll explore its incredible movement. And finally, we'll see how this all comes together in a brand new model.
The very first clue came from Webb's direct images, and that so-called smooth donut? Yeah, it was anything but. Instead of some uniform ring, Webb revealed this messy, complex structure just full of clumps and wispy filaments and dense little knots. That perfect brick wall was actually, well, a lumpy, porous mess.
The second clue came from the dust's composition. Webb found these really clear temperature changes. It was way, way hotter the closer you got to the black hole. It also saw that specific chemical compounds were being literally destroyed by the intense radiation near the center. This wasn't some static, uniform block of material. This was a dynamic, violent environment.
The third clue is a number, but it tells a story of incredible power, -800 kilometers per second. So what in the world does this speed represent?
That number, that's the speed of gas being shot out from the galaxy's core. We're talking about a massive, powerful wind being driven by the black hole itself. This isn't some passive cloud of dust just sitting there. It's an active system where the black hole is violently pushing matter away, actively shaping its own environment.
And the final clue, well, this one seals the deal. When astronomers fit all of Webb's new data, the clumpy structure, the temperature changes, that high-speed outflow, into their computer simulations, only one model actually worked. The only way to explain everything Webb saw was if the torus was a clumpy, porous structure with gaps for light and heat to escape.
So with these 4 clues, the old picture of the hidden black hole was completely shattered. Let's take a look at the new reality Webb has unveiled. This discovery is a true paradigm shift. The myth of a smooth, opaque wall hiding the black hole is gone. In its place is the reality of a clumpy, porous, dynamic cloud that instead of hiding the black hole actually helps reveal its activity through its gaps and outflows.
So if it's not a solid brick donut, what is it? Well, the best analogy is a giant, swirling, cosmic popcorn ball. It's lumpy, right? It has gaps between the pieces, and it's constantly in motion, a far, far cry from the static wall we once imagined.
This is a fantastic discovery for sure, but it's so much bigger than just one galaxy. This new understanding has profound implications for how we study the entire universe.
So here's the crucial point. The Circinus galaxy has become our Rosetta Stone. By finally understanding its core in such incredible detail, we now have a benchmark, a template, that we can use to understand the hidden hearts of countless other active galaxies all across the cosmos.
So here's what you should take away. This single set of observations solves major problems in astrophysics.
It gives us a new, much more accurate model for galaxies. It shows us exactly how black holes regulate their own growth by blasting out matter. And ultimately, it just transforms our understanding of how galaxies and the black holes at their centers grow up together.
Thanks to Webb, a part of the universe we thought was permanently hidden is now pretty much an open book. It leaves you wondering, with our new eyes on the cosmos, what other long-held myths are about to be completely shattered?